Intrusion Detection System, IDS, an overview. An intrusion detection system is a security solution designed to monitor network traffic or system activities for suspicious behavior and potential threats. The primary function of an IDS is to detect unauthorized access, malicious activities, and policy violations. Once a potential threat is detected, the IDS typically alerts system administrators or security personnel so that they can take appropriate action to mitigate the risk. Types of IDS. There are two main types of IDS: network-based IDS, NES. This type of IDS monitors network traffic for signs of suspicious activity. It is typically deployed at strategic points within the network, such as at gateways or routers, to analyze traffic between all devices on the network. NIDES can detect attacks such as denial of service, DOS, or attempts to exploit vulnerabilities in network services. Host-based IDS. This type of IDS monitors the activities on a single host or device. HIDs checks for unusual activities such as unauthorized file access, changes to system configurations, or suspicious log entries. It is particularly useful for detecting internal threats or attacks that have already bypassed the network perimeter. How IDS works. An IDS operates by analyzing data from various sources, such as network packets, system logs, or file integrity checks. It compares this data against a database of known attack signatures or baselines of normal activity. If the IDS detects anomalies or matches a signature in its database, it raises an alert. IDS can operate in different modes. Signature-based detection. This approach involves matching observed behavior against a database of known attack patterns or signatures. It is effective at identifying known threats, but may struggle with new or evolving attacks that do not have established signatures. Anomaly-based detection. This approach involves creating a baseline of normal behavior for a system or network and then flagging any deviations from this norm as potential threats. Anomaly-based detection can identify previously unknown threats, but may generate false positives if the baseline is not well defined. Advantages of IDS. IDS provides several benefits to organizations. Early threat detection. IDS can detect potential threats before they cause significant harm, allowing organizations to respond quickly. Compliance. Many regulations and industry standards require the use of IDS as part of a comprehensive security strategy. Incident response. IDS alerts provide valuable information that can help security teams investigate and respond to incidents effectively. Challenges of IDS. Despite their benefits, IDS systems have some challenges. False positives. IDS can generate false positives, alerting on legitimate activities that resemble malicious behavior. This can overwhelm security teams and lead to alert fatigue. Resource intensive. IDS can require significant processing power and storage to analyze and store large amounts of data, especially in high-traffic networks. Signature updates. Signature-based IDS must be regularly updated with new signatures to remain effective against emerging threats. Real-life use case, IDS in financial institutions. In a financial institution, an IDS is often deployed to protect sensitive customer data and prevent breaches. For example, a bank may use an IDS to monitor all incoming and outgoing traffic to detect suspicious activities, such as unauthorized access attempts or data exfiltration. The IDS would alert the bank's security team if it detects any abnormal behavior, such as repeated failed login attempts or large data transfers outside of normal business hours. This early warning allows the bank to take immediate action, such as blocking the suspicious traffic or initiating an investigation, thereby protecting the integrity and confidentiality of customer information. IDS versus IPS, understanding the difference. It's essential to differentiate IDS from intrusion prevention systems, IPS. While IDS is primarily focused on detecting and alerting on potential threats, IPS takes it a step further by not only detecting, but also taking action to prevent the threat. IPS can automatically block or reject malicious traffic in real time, whereas IDS requires human intervention to respond to alerts. IDS in modern cybersecurity. With the rise of cyber threats such as ransomware, phishing, and advanced persistent threats, APTs, IDS has become a crucial component of modern cybersecurity strategies. Organizations increasingly deploy IDS as part of a layered defense approach. integrating it with firewalls, anti-malware tools, and other security solutions to create a comprehensive defense against a wide range of attacks. Conclusion: intrusion detection systems play a vital role in protecting organizations from cyber threats by monitoring, detecting, and alerting on suspicious activities. While they are powerful tools, their effectiveness depends on careful deployment, regular updates, and ongoing management to minimize false positives and ensure timely detection of real threats. By understanding how IDS works and its place within a broader security strategy, organizations can better protect their critical assets and maintain the trust of their customers and stakeholders.